Hello students, welcome to my online class. Myself Firoz Sheikh, and today we are going to start with a new chapter. Chapter name is Factorization. What is Factorization? Factorization means writing a number in its product form. Simply, see, let's talk about the factors of a natural number. Suppose if I write 28, for example, what are the factors? See, 1 into 28 gives you 28. Okay, if we write 2 into 14 gives you 28. Okay, by 3 it is not possible. By 4, 7 fours are 4 into 7, 28, and then 5. No, by 6. So 6 fours are no. So see, these are the factors here. For 28, 1 is the factor, 2 is the factor, 4 is the factor, 7 is the factor, 14 is the factor, 28 is the factor. These are factors of 28. Or simply if you write to find the prime factors 2, suppose 14 here, 2, 7, 14, 7. So here is 2 into 7. These all 2, 2, 7. These are what? Prime factors of this natural number. But when we talk about factors of algebraic expression, let's take an example here. Suppose 3x plus 6. If we see here it is 3, it is x, this one is let me take a small example. Instead of taking this one, first take it as a 8xy, for example, this one. So this is one of the factor 8, this is one of the factor x, and this is y. 8 into x into y. So 8 is the factor of 8xy, x is the factor of 8xy, y is the factor of 8xy. Okay, now how we will do, or what are the methods of factorization in an algebraic expression? Okay, let's try to find this one. First we will use from the book, it is there is first a method of common factors. Okay, common factors. Okay, let's take an example. Just few minutes ago I have wrote that one 3x plus 6. Actually I by mistakenly wrote that common one. Let me write this one, 3x plus 6 here. If you look at here the factor of 3x is how much? 3 and x. Okay, and for 6 also 2 and 3. 3 into x gives you 3x, 2 into 3 gives you 6. In this term and in this term we can see this 3 and this 3 is common. So if we take 3 outside of this expression, in this term what left behind? X will left behind, and in this term what left behind? 2 will left behind. Plus sign is there in the middle, plus, and 2 left behind. So see, this 3x plus 6, 3x plus 6 can be written like this. 3 into x plus 2 means the factor of 3x plus 6 is what? 3, and another is what? X plus 2. Is that clear? It's very simple. There are two factors of this algebraic expression. In this way we can find for common factors to find the factors of an algebraic expression. Now the next topic in your book is what? Regrouping. Okay, regrouping. Let's see. I hope you understood this one, common factor. Now regrouping. Regrouping. Let's take an example from our book itself, from ncert. Twice xy plus 3 plus twice y, 3 plus twice y plus thrice x. Regrouping means we will rearrange, or we will take in pairs, and we will try to find the factors here. if we see here, in this case we have 2x and y, 3 factors. In this term we have only 3, or 1 into 3 we can say that. In this case, let me write 1 also. So 1 into 3 into, okay. In this case 2 into y. In this term only 2 and y are the factors, and in this term 3 and x is the factor. If we try to see all the terms, it is not possible to have a common factor in all the terms. So we can't use that one. Common factor we can't use, we can't apply in this expression, because here it is 2 but we don't have 2 here. Here we have 2 but we don't have here 2. So only these 2 terms are having 2. If we talk about x, so only this term and the last term is having x, but the rest of the terms we don't have any x, so we can't take a common x from here. In y also, in the first and the third term we are having y, but we don't have any y on the second and fourth one, so we can't use that one, the common factor. So in this case we will try by using regrouping, means pairing like that, okay. So in this 2 case, if we see, there is no common. 2xy here 3, here 2xy here 3, no common is there. In this case no common is there. But if we rearrange it, suppose, let me first write 2xy plus, suppose I write 2y, then plus 3x plus 3. In these 2 terms, see, in these 2 terms I can see here 2 is there and y is there, so I can take common from here, and in these 2 terms 3 is here. Let's see what will happen. If I take out 2y common, what will left behind? If I take out 2y from here, what left behind? Only x will left behind, x. Then plus, if we 2y take out, only 1 will left behind, because 1 is the common factor of each and every number. So what left behind? 1 will left behind. Then plus 3. If I take 3 outside, what will be left behind? X. And plus 1 as it is, I told you. So now again there is 2 terms here, and I already explained earlier while expressing what is algebraic expression. The terms are separated by 2 operators, plus or minus. So see here, one term is there, another term is there. In these 2 terms we can see x plus 1 is there, we can take common. So x plus 1, if I take common, what left behind in this term? 2y plus, and what left behind in this term? 3. So now see, the factor of 2x plus 2y plus 3x plus 3 is x plus 1 and twice 2y plus 3. Or again we can rearrange this one, 2xy plus 3x plus 2y plus 3. In this term we can see x is common, and in this term 1 will be common. So if we take out this x as a common, what will left behind? 2y plus 3, then plus, there is no common other than 1, so simply what we will take 1. So what left behind? Twice y plus 3. Again see, this is the term and this is the another term. In these 2 terms we can say 2y plus 3 is common. So if we take out twice y plus 3 outside, what left behind? X plus 1. See, same thing. So ultimately the factor of twice xy plus 3x plus 2y plus 3, or twice x plus y plus 2y plus 3x plus 3, or this one twice xy plus 3 plus 2y plus 3x, after regrouping we will get x plus 1 into twice y plus 3, 2 factors. One is x plus 1, another is twice y plus 3. This is what? Regrouping. Now we will talk about identities. Now the third process, we will use identities. Okay. First one is a plus b whole square, a minus b whole square, or a square minus b square. In this case what will happen? a square plus twice ab plus b square. In this case, a square minus twice ab plus b square. In this case, a plus b, a minus b. These are the three identities right now in your book, and we will use these three identities when the common factor is used up, or there is no way of using common factor, there is no way of using the regrouping. Then we will go for the third step, means identity. Then we will try to use these identities whether it will work or not. Let's take an example. Let's take an example from our book itself. X square plus 8x plus 16. X square plus 8x plus 16. So if we look this expression, it looks like either this one or this one, like this, these two identities. But here both the terms are separated by the plus signs. I mean all the terms by plus sign. Here also plus plus. So most probably it will be this expression. So try to find the value of a and b. So what is a? A here is x square plus b will be 4 square. So b is our 4. In the middle 2ab. So plus 2a is our x, b is our 4. Now check it. 4 to ja 8 and x. So it is a plus b whole square, means a plus b whole square. So x plus 4 whole square. So it justifies. Okay. Just always try to find the value of a and try to find the value of b. If the expression looks like this, then most probably the middle term will always twice ab, twice ab. If it is applicable for a plus b or a minus b whole square like this. So what you will do, try to find the value of a, try to find the value of b, and then simply write it down twice ab, and then recheck it after multiplying whether it is coming or not, this center. If it is coming, then simply you will write a plus b whole square. If it is minus, then a minus b whole square. Very simple. Okay. And in this case also, let's take an example from the book itself. M to the power 4 minus 256. See, it looks like this. A square minus b square. Let me try first. This one, m4 means m square whole square. Okay, so a square, we have value a square right now. Minus 256 means 16 square. 16 into 16 gives you how much? 256. So it looks like a square minus b square now. A square minus b square means a plus b, a minus b. So I hope you understood this part, how we will use identities. Okay. Now we will go for the splitting the middle term. This is a little bit important, and most of the question comes from this part only, splitting the middle term. Not only means it comes from identities also. Let's see. Splitting the middle term. Here also, let's take an example from the book itself. This one. Y square minus, how much it is written? 7y. 7y plus 12. Let's take an example. See, in this case, there is no common. Means you can find common all these three terms. So what? The common, finding the common factor is not applicable here. There is three terms are here, so we can't regroup it, cancel it out. If we go for the identities, check it out. A square, 12, we can't find anyone's square is 12. 3 3s and 9, 4 4 just 16. There is no way of getting 12 square. So the identities also failed out here. Now the last point, splitting the middle term. What we will do? First, coefficient of variables square, either x square, y square, p square, t square, whatever the coefficient, whatever the number is there in front of this. Right now there is nothing is there, means there is 1 into the constant number. You will multiply it. How much? 1 into 12 gives you 12. Try to find out with another number. 2 into 6 gives you, try to find all the factors. And 3 into 4 equal to 12. Is that clear now? So we have all the factors 1, 2, 3, 4, 6, 12. In this way we will get. So 12 we are getting 1 into 12. 12 we are getting 2 into 6. And 12 we are getting 3 into 4. Now, splitting the middle term means just try to see here 12 is there in front of 12 means the constant number in front of constant number is plus, means the middle term if we split that numbers, the 7 we should get by adding two numbers. Suppose if it is minus, then we will try to find the middle term by subtracting two numbers, but in your question it is given plus, means the middle term we should find by adding two numbers. So simply 1 plus 12 it gives you 13, so it is not applicable because it is 7. 2 plus 6 how much? 8, it is 7, not applicable. 3 plus 4 7, we can find it by adding these two. Okay, now simply what we will do, y square minus, either for 7 you can write 3 plus 4 then y plus 12, or you are a little bit more acquainted with the maths and all, simply you can write like this also, y square minus 3y minus 4y, means one step jump simply. But please, it's better you write this just for the value of 7. Please keep this thing inside the bracket, whether it is plus or minus, simply. So 3 plus 4, so you will ultimately get this one, then plus 12. Now these two terms, from these two terms what you will take? Y. So y you will take the what left behind? 2y. Y square means 2y is there, so 1y will left behind, minus 3. Then minus, here is 4, here is 12, means 3 into 12. 3 into 4 equal to 12. So 4 we can take common. So minus 4, if you take common, negative sign will come out, so only plus y will be there. Here plus, the minus sign will be there, minus 3. So y minus 3 you can take out. You will have y minus 4. So after splitting the middle term, the factor of y square minus 7y plus 12 is how much? Y minus 3 and y minus 4. Let me take another example where you will have minus sign in front of the constant. Let's take an example. This one. Z square minus 4z minus 12. Z square minus 4z minus 12. Again, see, there is no common term, so common factors is not applicable, regrouping is not applicable, we can't find out the squared number of this 12, so this is also not applicable. Ultimately we will follow the splitting the middle term. So once again what we will do, we will see the coefficient of variable square, z square. What is here? Nothing is there, means 1 into constant 12. Once again same thing, 1 into 12 gives you 12, then 2 into 6 gives you 12, okay, and 3 into 4 gives you 12. Now this time please look at here, in front of 12 is negative, means by subtracting two terms we have to find the middle term. 1 minus 12 or 12 minus 1, whatever you give, you will get 11, either plus or minus. It is not 4, cancel it out, it is cancel. If you talk about this one, 3 minus 4 or 4 minus 3, whatever, you will get plus minus 1. It is not applicable because it is 4. But if we see here, 2 minus 6 or 6 minus 2, we will get 4. How much? We will get 4. So let me write here, z square minus, for 4, 6 minus 2, simply 6 minus 2, then z plus minus 12. Is that clear? That is z square minus 6z minus minus plus 2z minus 12. Okay. z. Now from this term and from these two terms, we can take z. What left behind? Z minus 6. Here we can take plus 2 common, z minus 6. From these two terms, again z minus 6, z minus 6, z minus 6 and z plus 2. If we take z minus 6 common, z will left behind, then plus z minus 6 also came out, 2 left behind, 2, z plus 2. So you can say the factors of z square minus 4z plus 12 is this one, z minus 6, z plus 2. So I hope you have understood this part very nicely. We have explained the common terms, we have explained the regrouping, we have explained the identities where you will get a plus b whole square or a minus b whole square, whatever, and you will get the factors like this. Suppose twice x plus 4 whole square. So what you will write? Twice x plus 4 into twice x plus 4. Because we are finding factorization, means we need to write this thing in factors. Square means 2 times we will write it. Okay. In this case, for minus, suppose x minus 3 you are getting whole square. So you will write x minus 3 into x minus 3 to express this thing. Okay. I think I forgot to show this thing in the identities. Anyway, so wherever you will get in square form, you will write 2 times, because we need to find this thing in factors. So we are getting factors here, just like this, z minus 6, z minus 2, and rest of the questions. So I hope you understood very nicely. Thank you.